questions on 31? Let's start with the tangent graph. What is the period of that tangent graph? People? 16. Beautiful. Is the normal period of tangent 2 pi or pi? Pi. Okay, so if we take pi divided by 8, then you get a period of 8. Okay, so remember, tangent's a little narrower. It goes through a full cycle within pi, not 2 pi. If this had been a sinusoid, then 16 would have been right on. This is a tangent curve. The period's a little different. So it's 8. Now, with that said, 8, centered around the origin, I'm going to go from an asymptote at 4 to -4. It's always nice if you can make sense of this. Why does that make sense that there's an asymptote when x equals 4? Talk to me. Because it's 0, what's 0? If you put 4 in, what do you get? Tangent of pi/2, and that's a problem, right? Right, okay, so it makes sense. I mean, check does that make sense? Yeah, 4, there's a problem, because tangent of pi/2 is undefined. All right, what about at 0 then? What is tangent of 0? 0 times 3 is? Still 0. What about at the quarter wave points like 2? Tangent of 2 pi over 8 is pi over 4. What's tangent of pi over 4? 1, but then times 3 is? 3. And so you would look at something like there. And at -2, you'd be at -3. So you're getting tangent curves that look like that. Is that what your picture looks like? Okay? Now don't forget to graph over the entire space provided. So over here, I could go 2 boxes over from the asymptote and put that lower point, middle point, upper point, and I can't get a full wave there, but pretty close. Over here, 2 boxes from the left of the asymptote is upper point, middle point, lower point, and again, just shy of a full wave, but you should graph those 2. Do you agree? All right. How about the answer to 12 to estimate 7.8 to the 2/3? This is on the test tomorrow. I'm a little worried. Are you going to be good at tangent lines?
Yeah.
That's the spirit. If I recall, at least somebody said yes, so that's the spirit for you. If you said no, then that's not the spirit. The idea here, I believe, was y equals x to the 2/3 was the function, and the good point is if x equals 8, what's the 8 to the 2/3 going to outcome? 4. Okay? So from that, you should have had a good point. The tangent line is the derivative at 8. And so something like 2 over 3 times the cube root of 8, which is 2. So that's 1/3 for your slope, right? Is that what you got for your slope, 1/3? Yes, no, I hope. Do you see, if you didn't, do you see now why it should be 1/3? Okay, so your tangent line then. Now that you have the slope staring you in the face, the point staring you in the face, what's the tangent line? Y minus 4 equals x minus 8. Okay? Now that's the first skill, find a tangent. Second skill, use the tangent. So how do I estimate 7.8 to the 2/3 then? Yeah, you just plug 7.8 into your function. Y is 4 plus 1/3 of 7.8 minus 8. This would probably be a no calculator problem. I hope you can work out the skills there. I might go fraction, for example. So what is 7.8 minus 8 in fraction form? -1/5. So 4 minus a 15th is 3 and 14/15. Is that cool? Cool. Okay, moving along to the old differential problem. How will this go tomorrow when you see it? You're going to say, yeah, I can do this, or uh-oh, I don't know what I'm doing. Which one? Yes, I can do this. Okay. So this one's a little harder than you might expect because it has a skill that you're going to need as we go on through this class. But this, we haven't practiced a lot. So this, don't freak out if this is a little harder than you're comfortable with. Tomorrow's will be a little more like what you're used to. That said, you've got a cone. Boom. The radius is always equal to the height. That actually could vary depending on the viscosity of the material you're working with. The cone could look differently based on how far it's sticking. Yeah? So, at one instant the radius is 3 meters. Okay. If the radius increases by 20 centimeters, estimate the corresponding change in volume. So, get started. What do you want to do? You want to find change in volume, which in calculus notation is dV, okay? It's crucial to me that you make the connection to dV is what? Now, let's go here. The derivative is change in volume with respect to changes in radius, okay? And that is V prime. So if I split those, then dV is V primes times dr. How fast they change with respect to each other times the amount of change in radius tells you how much change in volume. All right, though, here's the problem. The function is a little wonky. We need to get that function. What is the volume of a cone? 1/3 pi r squared times height. That height's a bit of a problem. What's the solution to that problem?
It's the same as r.
It's the same. So we can actually say volume is 1/3, or pi over 3 if you like, r cubed, or pi r cubed, yeah? Something like that. All right, now that's nice then because the derivative just is based on one variable. When you have two, that's kind of problematic. So in this case then, what's the derivative? Pi over 3, what do you do with it? Put it in front, and then take the derivative on r cubed, which is 3r squared. Okay. Now we want the derivative evaluated at a number. What number? At an r of 3. I agree. Okay. The dr. What is the dr? Plus or minus? Plus or minus or strictly plus? Strictly plus because it increases. So 0.02. Oui, oui?
Yep.
Would it be 0.2? Why not just 2?
It's a unit issue, yeah. Because, in meter terms, you don't want a mixture of meter centimeters. 20 centimeters. Oh, so why not 0.2? That's a great question. To which I would say, because I'm an idiot, 20 centimeters is in fact not 0.02 meters, it's 0.2 meters. Thank you. There's one error I will have to fix. You're absolutely correct, Mr. Marlowe. Okay, so 0.2. So at that point we're evaluating, the 3's drop out, we have pi, feel free to leave your answer in terms of pi, that's fine. Times 9 times 0.2, so maybe 1.8 pi units? I do expect units.
Meters?
Meters cubed, because it's changing volume, right? Okay, how'd that go? Okay then, moving on to the backside replacements. I think there was a graph. I thought there was a graph. Oh, here it is. Okay. Reciprocal graphing, the 1/f is not on the test. It was set 30, which was Monday, and so still a little new. So don't worry if you're still not there yet. The derivative graphing, I'd like to try and put a basic one on tomorrow and see how it works. So we'll see about that. What's the reciprocal idea going on? When the original function is small, the reciprocal is big. Give me another relationship. Where one's positive, the other's positive. The one that really gets me started is the zeros. What about them? asymptotes. Where this had zeros, the reciprocal will have vertical asymptotes. So we're going to have vertical asymptotes at -2 and 2. Positive-positive relationship means here, if this is positive, I'm positive, but as this gets big, this gets small, so the shape should be something like that. You with me?
Yeah.
Okay, in here, small would be big, and small would be big. Negative is still negative. What's the relative or local maximum value of the function? Negative. -4 is the original function, so the reciprocal. What will the reciprocal be? -1/4. It'll have an actual, where this has a minimum, the reciprocal will actually have a maximum at -1/4. It does not touch the axis, it's at -1/4. I don't know if I have grade for that, but it's nice to have a number or two to look at if you could. And then this is symmetric. You can see that in terms of symmetry, what do you call a function that's symmetric about the y-axis? That's a blank function. Like x squared, or x to the 4, or x to the 6. What do you notice about the even? Yeah, that's an even function. Notice that an even function has a reciprocal that's also even. Okay? All right, the derivative. How did the derivative graph go? All right, start with flat spots. I can get a flat or horizontal tangent at x equals 0, which means the derivative is 0 at x equals 0. Before that, the derivative is the tangent slope, and the tangent slopes are negative. Therefore, the derivative should be negative down here, and then they should go positive. So I'm going to go negative to positive, passing through 0. Are these slopes big numbers or small numbers? Small. I mean, you think rise over run, it's like 1/5. Those are tiny slopes. So where will the curve be? If these are tiny slopes, then what would be a tiny negative number? It would be like here, right? You with me? Now, these are going to get bigger, so these will get bigger, but then don't they start in here, don't they start to go back to being smaller? And so they'll get a most steep point, but then they'll start to head out there. And then what happens after that? They start to get bigger, but then smaller. Notice that the original function was even. The derivative is odd. Okay, think of x to the 4th. Okay, what's the derivative of x to the 4th? X cubed. Okay, even function has a derivative that turns out odd. All right. Let's go to the next one. Is f continuous at x equals 4? Did you say yay or what the heck? I don't know if is that what I intended? 4?
Yeah.
Sure, that's what I intended. Go for it. What, is it continuous at 4?
Yeah.
Yeah. Is that kind of a weird question? Yeah. Usually, isn't the piecewise question about hey, at the handoff, do they meet? But where's 4? Right in the middle of the body of the second one. That's linear, right? Is this a linear continuous? Yeah. Okay, so f is linear at x equals 4. It is continuous. You could do the whole definition of continuity. As does the limit as x goes to 4 exist? Yeah, what is the limit as x goes to 4? 0. Does f at 4 exist? Yeah. Does it tell you what to do when x is 4? Well, yeah. When x is 4, that would be in this case. Yeah, it's this. Exists, and it equals 0. And so because the limit equals the point, yes, it's continuous. If you wanted to show it by the definition of continuity, that's what you would do. You follow? Alrighty then. In the end of those, there's some good AP style questions here. Oh, 2 is a humdinger. That one was tough, huh? I don't know about you, but I thought that was, we'll see. Okay, what kind of derivative rule do you need to employ for number 1? Product rule, okay? I can guarantee you, at least on the AP test, they will have the common error of, do you think you can just take the derivative of this, take the derivative of that, and multiply? That'll be there, and it'll get you if you're not thinking clearly. So we know that the derivative is first stays the same. Did that say square root? Times the derivative of the second. What's the derivative of the second? It's a cube. Okay, thank you. What's the derivative of the second? Negative 2x to the negative 3, or negative 2 over x cubed, if you like. And derivative of x to the negative 1? To the negative 2, which is the same as that. Plus second stays the same. Times the derivative of the first. What's the derivative of the first? 3x squared minus 2. Okay? Therefore, the derivative at 1 would be 1 minus 2 plus 5 times negative 2 minus 1 plus 2 times 3 minus 2. Yeah? Yeah, these gave us 1 to work with. That was nice. So we get something like 6 minus 2 is 4 times negative 3 plus 2 times 1. Negative 12 plus 2 is negative 10. How'd you do? Success? All right. The next one is hard. Why is the next one hard? Seems like product rule is so easy. How could they make the product rule hard? What's hard about it? Yeah, there are 3 factors, yeah? I guess I'm using the fork for my own. Okay. Here's where I had the hardest time with these. So this is what helped me. And if you got this without doing this, that's fine. But don't try and do it all at once. That's where most people make a mistake. I would just kind of lay out my plan here. I would say that if I want the derivative at 1, first of all, let's find the derivative at x. Don't worry about 1 yet. Find the derivative generally. Wait a second. This isn't hard. I thought I had a 3-part product in here. Is that on another homework? Didn't I put a, is there one on 32 where you had 3 pieces?
Yeah.
Oh, that was 32. Okay, sorry. This one's not hard. Never mind. My bad. So, by product rule. First stays the same, 3 f of x. I'm just going to include 3 in with the x of x. You could put it all the way up front and back. Times the derivative of the second. Plus second stays the same. Times the derivative of the first. That's 3 times f prime. Wait. So h prime at 1 is 3 times f at 1 is 2. G prime at 1 is 0. G at 1 is negative 3. 3 is 3. And f prime is 9er. So I get 0 minus 81. Did you get negative 81? We? All right. Other questions on 31?
Number 19.
19, okay. Marker. 19, any others on 31? 20? Okay. All right, let's do that.
Is that it?
All right. 19 is just, there it is. 19 is not a replacement. No, I already did replacement. So 19 is, okay. So it might have been the case that you did all the algebra right, but the solution wasn't in the domain. Sometimes that's an issue. I don't remember what was my issue with this. What did you do first? Log rules?
Yeah.
So you can put all those together So actually, let's make sure you didn't do the first mistake. The one mistake is commonly just say, all right, you just take the logs out. You can't do that for sure until you get it down to one log and one log. So your goal needs to first be combine all. This would be x squared over x plus a half. That's your first step. So then you can exponentiate both sides, which is to say e both sides if you want to get less fancy pants. X squared over x plus a half equals 2. Do you agree with me so far?
Yeah.
Okay, so is that what you do? Okay, so if I multiply the denominator over, I get 2x plus 1. And if I then move everything to one side, I would get this. As much as I wanted that to be able to factor, it seems like it does not. And so, by quadratic formula, 2 plus or minus 4 minus 4 AC over 2A is 2 plus or minus root 8 over 2, which is 2 plus or minus 2 root 2 over 2, which is 1 plus or minus root 2. Yeah? Now remember, root 2 is about 1.4. So in terms of what's allowed, 1 plus root 2 is probably about 2.4, and that seems like that would be okay domain-wise. But 1 minus root 2 is negative, and so that would be a violation of the domain for this guy, and that's a no. So I would say one solution of 1 plus root 2. Does that make sense?
Yeah.
Okay. 20. Question on 20. Let's see here. All right. There will still be limits. Limits aren't going anywhere. There'll be some on the test, so I'm glad you're asking about this. It'll get me in a limit. Bear in mind, 2x squared plus 3x minus 2. And x squared plus 4. If I get 0 on the top only, what does that imply graphically? 0 on the top implies what about the graph? What? Y-intercept? X-intercept. Okay? If x equals 0 on the top, the whole thing equals 0. If the whole thing equals 0, remember, you're finding what does that thing equal, that function equal. That means y equals 0. Y equals 0 is the next intercept. What if the bottom equals 0, but not the top? Vertical asymptote, okay? What if you get 0 over 0? Whole. Okay. Now in this case, then, when you plug in, you try and plug in, you get something like 2 times 4 minus 6 minus 2 over 4 plus 4. And so I get 0 over 8. Is that a problem does not exist, or is that just 0? It's just 0. Okay, so try direct substitute. Don't assume, oh, we got to factor and all this stuff. It wasn't that common. You just direct sub. Does that make sense? Okay. Other questions on 31? Then on to 32 we go. 32. Let me do a little cutting and pasting of those bad boys. Bad boys, what you gonna do? What you gonna do when they come for you? Do 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 do. Do 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 do. Name that tune. Nobody?
What?
I said name that tune.
It's a Christmas song.
Yeah. The melody is supposed to is Greensleeves or something, isn't it? Is that the name of it? Somebody who plays music? Greensleeves? No? Yes? Got nothing, huh? Never mind. Maybe somebody online is listening and will shoot me an email and tell me. All right, here we go. So I desperately want to see improvement on the last test. The last test, there was a bit of an issue in understanding the connection of limits to asymptotes. So by way of review, if the limit as x goes to a constant is infinite, then what's happening? Draw a picture. All right, so x is going to a constant, y is going to infinity would mean vertical asymptote at x equals c. If, however, x goes to plus or minus infinity and the function approaches a constant, then that's more make a doodle. Here's x goes to infinity, y goes to a constant. That's horizontal asymptote at y equals c. Yeah? Here we go then. To get a horizontal asymptote, we then really need to say, all right, is there a place where the end behavior goes to a constant? Horizontal asymptote is end behavior. What about the end behavior? As x goes to infinity, this goes to 1 or negative 1? Negative 1. There is a horizontal asymptote at, therefore, please do not just say negative 1. That's not an equation. Y equals negative 1 because justify it with a limit. The limit as x goes to plus or minus infinity of g of x, not f of x, is negative 1. That's the justification, the limit justification, all right? Vertical asymptote is where I, instead of looking at end behavior, I look for zeros in the denominator. Are there 1 or 2? Actually, are there 1 or 2? There are 2 zeros, but are there 2 asymptotes? Let me say it that way. Okay? If it's 0 over 0, is that an asymptote? No, that's a hole. So how many asymptotes are there? 1. There's 1 vertical asymptote. There's a vertical asymptote at x equals 2 because, how do I justify that with a limit? The limit as x approaches 2 of the function goes to, now, if you really wanted to do this beautifully, you would say from the left it's infinity and from the right it's negative infinity. But for me, I'm okay if you say because it's infinite there. That's fine. All right? Are you with me? Alrighty then, last but not least, H, horizontal asymptote. Again, we say end behavior. End behavior means take the limit as x goes to infinity. The limit as x goes to infinity, what would it approach? 0. Why? Yeah, it reduces to 1 over x. X cubed over x to the 4th. X to the 4th wins. And if you get 1 over huge, it goes to 0. So we would say there is a horizontal asymptote at y equals 0, also known as the yes, because the limit as x goes to plus or minus infinity of h goes to 0. Because the limit goes to 0, y goes to 0. It's an asymptote. What about the vertical asymptote, which is identifying any non-wholly 0 in the denominator kind of questions? Do I have any zeros in the denominator? ¿Cuántos ceros? Dos. Okay, so we have asymptote, vertical asymptotes at x equals or y equals? X equals 0 and negative 2. Darn it, that means 2 limit statements. That stings. Because the limit as x goes to 0 of h is plus or minus infinity, and the limit as x goes to negative 2 of h is plus or minus infinity. How I expected you to write that in that little space, I have no idea. All right, are we cool? All righty then. How about the tangent line to estimate? Were you able to get started? Sometimes these are hard because you're not sure how to get started. What's the function? What's the good point? Were you able to get started? Okay. So what is the function? Actually, start by asking yourself, what's this like? 2 to the 5th, okay? Now in terms of what's staying the same, what's varying is we're changing from 2.1 to 2, which probably means the function has a variable of x at that bottom. And the power is always 5. So I'm thinking the function is x to the 5th. The good point that we always do when we find a tangent line is 2 or 2.1? 2.1 stink, it's 2. If x is 2, what's the y? 32. It sounds like many people got this. That's fantastic. So now that we get on with the tangent line, we have a point. Now we need a slope. How do we find the slope? Take the derivative. Communicate your thinking, saying, hey, the slope is, or m is, the derivative at 2, yeah? Okay. Be careful with notation, please. If, for example, this gradually gets you built up to this, but if I were to say f prime at 2 is 5x to the 4th, I would actually lose points on AP exams for saying. Why? Yeah, I'm making a mixture of the derivative at 2 versus the general derivative. Those aren't necessarily the same. So if you do this, you can do this just to say as long as I'm going to say that's at 2, that is to say there, all right? Or something that's true, say it in 2 steps. The derivative at x is 5x to the 4th, and now the derivative at 2 is this, all right? Don't mix them together unless you make sure you make clear that you're doing it this way. So that's 80, yeah? All right, so what's the tangent line? Y minus 32 equals. Okay, so great. Now how do I use the testing? Plug it in. I plug 2.1 in. So y is 32, which really represents the starting point. And now we're going to calculate the amount of expected change. It's kind of like a differential problem, really. I take the rate at which it's changing times the amount of change in x to get an amount of change in y. 32 plus 80 times 0.1 is 40. How'd you do? I'm kind of curious to see how close that is. What's 2.1 to the 5th? Because this is so intensely growing, it's probably going to have some stem. No, it's 40.34. It's not bad. Okay. It's going to have some errors sometimes when the function is high growing like that. All right. This, give a piecewise function involving y, provide it, make it continuous, show it's continuous. If you were to graph this, what's the easiest way to graph this? Find the hole. There's a hole at x equal negative 2, and everywhere else, that then can be removed, and then I can just say, all right, well, it's kind of like the graph of 2x minus 4, just with a hole. So I can graph 2x minus 4, and there's a hole at negative 2. Something like that, yeah? Okay. Now, if you were to make this continuous, right now it fails to be continuous because the point is undefined, yeah? So I can make it continuous by defining the point. Here, you could put the original function. What could you also put there? Simply. You could say it's like the function 2x minus 4. The only exception is that that doesn't work at negative 2. And say, all right, now to fill the hole, I need to put a dot there. So when x is negative 2, what does y, or the function, need to be? What y value would fill the hole? Negative 8. Now you could do that graphically. You could also do it limit-wise. You know that the limit as x goes to negative 2 of that function is what happens as you remove the hole. If you go to negative 2, doesn't this want to be negative 8? And so the limit is negative 8. You fill the hole with the point negative 2, negative 8. We? This is the three-part derivative I thought I had given you, but this is where it came. So you've got three factors. That makes things a little harder to run the old product rule on. You might consider doing this in 2 stages then, maybe even 3, because then we have to put in 1. So let's call it h prime of x. I would suggest maybe you call this term 1 and this term 2. First stays the same, x. Now derivative of the second. What's the derivative of fg? By product rule, the derivative of fg is first stays the same, derivative of the second plus second stays the same, derivative of the first. Okay, now don't get lost. I said first stays the same, derivative of the second plus second stays the same, which would be just f of x g of x times derivative of the first. What's the derivative of x? 1, right? So you get this crazy mixture. Now we need to find h prime at 1. 1, what's f of 1? Negative 2. What's g prime at 1? 1/2. G at 1. 3. F prime at 1. 1. Plus f at 1. G at 1. 3. So I get 1 times negative 1 plus 3 minus 6. 2 minus 6 is 4. How'd you do? You win? No. Okay. Good try though. All right. Other questions on 32?
21.
21? Was there another one after that? Or just
Well, 22 is based off of 21, but 22 would make more sense.
okay. Others? What's that? 9? I didn't hear it.
Yeah, 9.
9. Okay, I'm sorry.
8.
8? Okay. All right. 24. 21, which then will follow the 20 by 22, they're related. Okay, set 32. 22. Here we go is all right. Sine of A is a third, and cosine of A is positive. What's the exact value of cosine A? Sine of A is a third. This is a classic trig problem in other books. Cosine of A is positive. What is cosine of A equal to? Now, you could do this 2 ways. Analytically by identity or graphic. If you did this by identity, what's an identity that relates sine to cosine? Sine squared plus cosine squared is 1, yeah? Okay. How does that get you started? Well, sine of A is 1/3, then this is 1/9 plus cosine squared of A is 1. So cosine squared of A is 8/9. So cosine of A would normally be plus or minus 2 root 2 over 3, but they said A is positive, so or cosine is positive, so it's just 2 root 2 over 3, right? By graph, it's a little better. Graph is sine is opposite to hypotenuse. So implied within sine is 1/3 is that the opposite side is 1, the hypotenuse is 3. And I'm drawing it in this quadrant because if sine is positive and cosine is positive, it's got to be first quadrant. Now to find the cosine is adjacent to hypotenuse. By Pythagorean theorem, what's the adjacent side? 2 root 2 over the hypotenuse 3. And that's another way to do it. Cool. 22 then will make more sense now that you have cosine of A. Should we go through 22? Still, I guess it's not a home free necessarily yet. Yes? No? Talk to me if you can.
Yes.
All right. So this requires some identity work on your part. Okay. So check this out. Sine of A versus negative A. When you do a negative, that's an angle, right? Now when you do a negative angle, instead of going up, you go down. So sine of negative A would be like saying, if you go down, what's the sine? Does the sine get affected by going down? Well, yeah, sine's the opposite side, so it's going to be affected. And so this is negative 1/3 there, because we went down 1/3 instead of up 1/3. Cosine of pi over 2 minus A. That's 90 minus A, yeah? The idea there is that if I look at any angle, say this is 20 degrees, then, and I call this A, B, and C, isn't the sine of 20 degrees, which is A over C, the same as if I took the cosine of this angle, which would also be A over C because it's adjacent? You see what I mean? So the idea is these are called cofunction identities. The sine of the other angle in a triangle equals, the cosine of the other angle equals the sine of the angle. Cosine of pi over 2 minus A is the same as sine of A. It's the other angle in the right triangle. And sine of A we know is 1/3. The cosine of A we found in the previous problem was also, not also, 2 root 2 over 3. So negative 2 root 2 over 27 is right. Cool? That was a good one. 9. Question on 9 still. Yes? No? Okay, 9 you can skip because we are in no way ready for that. I meant to scrap that. You may skip 9. I don't like how he teaches differentials. I do not. I absolutely detest how he teaches the chain rule. So none of that means anything to you. Just skip 9. 8. Question on 8. Yes, 8? All right. 8 is yesterday's big idea. Okay? They're giving you what the derivative is, and they want y. Well, to get y, I have to get rid of this. This means the derivative. What is the inverse of derivative? Integral. I'm going to integrate this side and integrate that side. The antiderivative of the derivative is just the thing. Here's where a little bit of a gotcha. What gives you a derivative of 1 over x? Natural log, but you don't forget the absolute value. And then there could have been a constant there that went away with the derivative. I don't know. So there's your answer. Okay. 24 says the square is on a plane, blah, blah, blah. Find the slopes. How the slopes related. What does this indicate? Okay. What's this slope given that that point is AA? What's slope 1? A over A, also known as 1. What is slope 2? Given that this is A0. Negative 1 rather. Sorry, negative 1. What does this indicate? If these slopes are related in that way, that indicates that the slopes are negative reciprocals to each other, and so perpendicular slopes, yeah? That implies that diagonals of a square are perpendicular. I will be happy to, I will make a key to that review. I'll put it on my website tonight so you can see how you did. I'll be here, seventh period, not after school, sorry, I have a meeting, and I will be here before school tomorrow. Have a great day. 31 and 32 are due today. 31 and 32 are due today. Anybody borrowed my Conspire, please return it to me. Yeah.
Think of a meeting with your bunch of class after, right?
What? No, I also will be going to Colorado Springs for a volleyball game, so no, I am not available after school today.
Okay, but I can come before school tomorrow.
Yes, I will be before.
To finish that sentence.
Okay,
Thank you.
you bet.
Turning one in.
Dude, is this yours, Kenny? Then share.
Oh, shoot.
Share.